Hello, good evening. Welcome to this AHDB Dairy webinar. I'm Jamie McCoy. I'm one of the Knowledge Exchange Managers at AHDB in the Dairy team, and I'm joined today by my colleague Tegan Taylor and the very brilliant Ray Archuleta. Thanks for being with us this evening.
Thank you, Jamie.
Before we get underway, I've got a couple of housekeeping things to cover. Some of you will have listened into our webinars before, but we would like to make this as interactive as possible. So all attendees are muted and you can ask questions anonymously, so we won't share details of who's asking what, so no such thing as a silly question. If you're thinking it, someone else will be as well. To ask a question, use the questions box, which you will see over in the right hand side of your screen. You may need to use the orange arrow to pop the control panel out, and if you scroll down to questions, drop down there and you can type your questions in there. If you'd like to register for Dairy Pro Points, please just type your name, postcode into the message box and we'll pick that up later. If you're watching again on YouTube, then thanks very much. Remember to hit subscribe for more from AHDB. But this evening we'll be running through some presentations and we're hoping to take questions as we go. So, regenerative agriculture, or Regen-Ag, I suppose it's being quite commonly known as. It's a really hot topic in UK dairying at the moment, but it means different things to different people. Environmental sustainability has been kind of buzzwords here for many years, and targeting net zero is very, very firmly on the political agenda at the moment. So I'm going to call on Tegan, if that's okay, just to run through why at AHDB we really wanted to do this webinar. Thanks, Tegan.
Thanks, Jamie. Hi, everyone. I'm just going to spend a few minutes before we hear from Ray speaking about, why we're here today and why this is really, really important and why we tasked these events or called these events our journey to net zero. So the NFU has set a really ambitious goal of reaching net zero for the UK agriculture by 2040, and this will be a part of the UK's ambition to be net zero by 2050. We have a really high drive from our consumer for increased sustainability on our producing systems. We need some productivity increases within the industry, and we need to make sure that we're really resilient in our businesses to keep driving forward. We've got this big pledge. We need to seek some understanding about how we're going to meet this target as an industry and as individual businesses, and what are the steps we're going to take to increase our sustainability across the agricultural sector. What do we know? So work with AHDB across Wales completed a selection of carbon footprinting across dairy farms. And we know that there were 5 key focus areas of advice given very commonly throughout these carbon footprinting. Optimising livestock health and performance, reducing age at first calving, managing our replacement rates, managing our non-productive stock numbers or reducing those, improving our health and performance indicators, mastitis, lameness, transition diseases. We need to focus on our soils and fertilisers and use of manures. Are we putting on our inputs at the right time so that we can get the best productivity increases from our land? We need to look at our feed efficiency and our feed sourcing, improving our forage quality and quantity, our homegrown proteins, and sustainable sourcing methods. We need to look at our energy use and fuel consumptions. Are we using renewable energies? If not, why not? What could we be using? And are we locking in our carbon and our carbon source, protecting our current carbon stocks and increasing those? So today is really, really important. We need to get experts on, like Ray, to be able to help us meet this big target that we've been set. Every business is going to require a different set of solutions, and we're here on the journey with you to try and find those. Overall, the focus has to be on moving the industry forward together. I want to leave today with a quote from a colleague of mine, Nick Parsons, and he had to say, that fundamentally a farm has to be sustainable from a profitability point of view before we can really invest in innovative technologies or practices. And today, that starts today, taking small steps so that as technology develops, we are able to take advantage of it and meet this net zero target by 2040. Back to you, Jamie. Thank you.
Thanks, Tegan. Yeah. So in our attempt as an industry to target net zero, carbon storage, I guess, has a role to play. And you know, you can't think about carbon storage without thinking about soils and the cycle that starts with the sun. So I guess when we think about all of that, and every time we think about soils, lots of people will think of Ray. Ray the soil guy, I think actually the term has been coined, hasn't it, Ray? Yeah. So that's who we've got with us. Thank you so much. Ray, you have got a soil CV which is about as long as my arm, and I don't think that people will be able to read the slide, but there is a plethora of experience having worked in soil academia. You've worked with water quality and conservation, of course, but a lot of people will know you from the Netflix documentary, which is called Kiss the Ground. Right. And I know that that's been instrumental in a lot of people in Britain, just inspiring them to take the first steps and to start exploring more about regenerative agriculture and what can we learn about soil. And one of the things I'm always struck by is the more we learn, the more we realize how little we know. But however, we are here tonight to try and garner a little more information and try and take those few small steps, I suppose, to improving what we're doing on our farms. And I understand that you are now spending time on your own ranch in Missouri, is that right?
Yes, Springfield, Seymour, Missouri. Yes, I run hair sheep. I got a 155-acre farm, which is about 66 hectares in my own place. So yes, I felt like if I'm going to teach, I better do it myself, Jamie. So that's great.
Fabulous, walking the walk. Well, what better place can we start then, Ray, by just asking you to start with, what does Regen-Ag mean to you?
Beautiful, Jamie, thank you. And beautiful people of England, good evening. I'm so tickled to be here. Thank you, Jamie, for inviting me. And you got to give, every time you see Emily, give her a big hug, because she has to deal with me and my technology apps. And Tegan, it was neat how you bullet all that. And, really, when you look at all the bullets that Tegan was going to address, regenerative agriculture addresses all of them. And there's a lot of definitions out there in the country, and I coined this phrase, regenerative agriculture is a journey for life. It's the renewal of the human heart and mind. The most difficult thing, Jamie, to change on the ranch and farm is what's between the ears, how we've been socially conditioned for the wrong goal. It's a new way of thinking that loves and emulates, like people say, nature. I say the creator's intelligent design. It's just this simple: mimic the natural system. And that's what's not. This was not taught to me at the university. So a lot of times people don't realize that little all that experience and all that education. One of it should say all those years of failure. We failed here miserably in the United States because things weren't working. And regenerative agriculture is a renewal. And I just want to say one more thing about regenerative agriculture before we go on to the next slide. If I ask people, what kind of marriage do you want? A sustainable marriage or a regenerative marriage? And people start to laugh. If you have a sustainable marriage, life sucks for you. I'm going to tell you right now. I want a regenerative marriage, something that's live, always growing, always changing. It's always doing it with the natural system, always renewing. So I think that's the proper, regenerative agriculture is a agriculture that's always renewing and always emulating the natural system. So let's go on to the next, move on from there. And regenerative agriculture should do this. It should be dependent and should run on new sunlight, not ancient sunlight. Our current agriculture system, ladies and gentlemen, are driven by ancient sunlight, fertilizers, chemicals, the pesticides, all the infrastructure, ancient sunlight. If you are truly a regenerative farmer, all your inputs would be lessened and completely start disappearing. I'm talking about the herbicides, the fertilizers, the chemicals. Your human, I mean, a huge carbon footprint starts to diminish, because a lot of people forget. They just think about the carbon in the soil, but it's not running on ancient carbon, and that's what the current system. So that picture I have right there is regenerative agriculture should be beautiful. It should emulate the natural system. You should be able to hear it, and your inputs should be able to go down. And so that's the beauty about that. And so, so as you can see, one of the problems with most agriculture systems is that it's very costly, and it takes a long time for producers to make money. In fact, they're not making money. As you can see here by this slide, this is a very common thing. See, if you look at 1920s, the 20s, the inputs were high since the 20s. Look at all the way into 2016, you can see the graph there, the income. And this is why we were failing, as I could see that we weren't cleaning the water. And I think it was about halfway through my career, I was about 40 years old, and I said, something's wrong with agriculture. I can't get it. I can't put my finger on it. One, we're not cleaning the water. Second is farmers can't bring their son and daughter into the operation. And it was in Idaho. We had 500 prime acres, all the water they could think of for irrigation, and the soil was in good condition. I mean, it was highly fertile, and yet could not afford to bring their son and daughter into the operation. I'm going, what's wrong with this message? And so it was very frustrating. So now I realize what's wrong. And the reality is we're working against the natural system. And as you can see this slide, I've been in every state, ladies and gentlemen, every state in the United States. This is kind of a pathway of my flights, from driving to flying, from Alaska to Puerto Rico to Hawaii. I started seeing the same common pattern. When I got, because I worked for the USDA for 30 years and I retired in 2016. And one of the things I wanted to do is I wanted to start teaching regenerative agriculture, how we can emulate nature, because what I was being taught in school is this was the paradigm I was taught. My job is to control the natural system with fertilizers, chemicals, high inputs, tillage, all these things I was taught in school. Not one professor taught me, Ray, your job is to emulate the natural system. I was not taught that. What we're teaching producers, how can we emulate the system, the natural ecosystem, because it works fantastic. How can we make our farming, our grazing systems, our dairies more like that? So as I'm waiting here for the next, beautiful. These are the common things I'm going to talk about today. We're going to understand the power of life. One of the things that just boggles my mind after I left to college, I did not understand the power of life. And everywhere, a lot of the places I teach in the United States, I don't care what university, where you went, that was a common thing. Not understanding that power of life and that diversity, and understand the basic ecosystem process and what we're going to talk about. I'm also going to talk about learn basic functions of soil today, the basic indicators, and always the most important thing here, folks, is understand the principles and patterns of biomimicry, how to mimic life. And I'm going to talk a little bit of what makes some of the farmers and ranchers different. Why is the top 1% making it work, and why the rest of them, the other 99%, struggle? What's the issue, and what delineates them from the whole herd? And I'm going to touch upon that at the end of my PowerPoint. And so the first thing I start realizing, folks, as I travel all over the country, is first thing farmers tell it, and you can see this how we were taught in our schools. Ray, regenerative agriculture doesn't work here. Cover crops, no-till doesn't work here because it's too cold. I hear that all the time. For every time I hear that, farmers tell me, Ray, it's too cold, it's too hot, it's too dry. Excuse after excuse. I hear this statement all the time. And oh, Ray, by the way, it's too wet. And I said, it's interesting. You're saying it's too cold, too dry, too wet, but what do all these ecosystems all have in common, folks? What do they all have in common? I tell the farmers, they're all driven by biology. They all have life. Every one of them have bacteria, organisms. Yes, even in the deserts, there's living bacteria in those systems. We are not farming in Mars. This is what we're farming. This is what's the life in the soil. And it was, Jamie said, we haven't even touched what's in that soil. 25% of all biodiversity is in the soil. Imagine all the terrestrial biodiversity, and the most 25% of it is in the soil itself. It is an amazing, amazing place. And so what we're going to do is learn how to tap into that. And the first thing I ask producers all the time, by the way, how in the world did that soil turn into, see, this is a picture in Australia. And I ask farmers, think about that's a gypsum seabed. And look at the dark layer on the top of that soil. And I ask farmers, how did that happen? And a calcium gypsum seabed of salt. How did that happen? And I tell them, it's the power of life. This is what we have not tapped into. This is what we didn't teach in college. They didn't teach me the appreciation and how powerful life is. And that's what we're going to talk about. How are we going to make our dairies and our systems much more self-regulating, more self-healing, and self-organizing? Is everything coming out okay, Jamie? Because I see your picture. Is everything okay?
Yeah, perfect. I hope you don't mind me stopping you, but I got a question coming in. You talked about, well, I remember we had this conversation when we were planning this webinar about, you said regenerative agriculture is about that promotion of life and avoiding farming practices that that do the opposite, so effectively kill things. And I wonder if I could ask you to just explore that a little around, give us some examples of practices that you would consider good and bad in those situations. Thanks.
Yes, good, Jamie. One of them is, and I have my organic brothers and sisters I work as, they give tillage a pass. I call tillage side. Side means to kill. Fungicide. It's meant to kill fungus, but people don't realize that the fungi, there's a lot of fungi in the soil that works for us. Herbicide, kill the plant. It kills plants. And some of them have carryover of some chemicals that are not always the beneficial. Insecticide, kill the insect. People don't understand that we have 1,700 beneficials, insects, for every one pest. We need to understand that. And so, too much tillage, too much haying, overgrazing, everything we do in agriculture in excess is hurting the soil. Poor rotations, leaving the ground bare. There are many. We're going to talk about that further down on the PowerPoint, because we are going to address that. Because life, all these insects, all these plants, all these animals help in the self-regulating, self-organizing, self-healing process. Our bodies do the same. If you want to know how the soil works, and start understanding how your body works, it's the same thing. It's self-healing, self-organizing, self-regulating. All those insects, all that biodiversity, that does this. We need to understand that. So if we do excessive tillage, not enough cover crops, not enough energy flow, that's what will happen. So please understand all those things we do in agriculture. Pretty much everything is pretty destructive. In excess, chronic, and we'll talk about that in a second. As soon as we can get to the next slide, and there we go. Folks, we're going to address how soil function, all the ecosystem processes, we'll talk about that, and indicators to see that the ecosystem processes are occurring. And if we have that, then we know that soil is functioning. They all are interconnected. Let's not ever separate those things out. How the earth, how the soil works, all that is worked together, and this takes observation. There's a great saying by Masanobu Fukuoka. It said, the fertility of your soils is dependent on how many footsteps you take on that farm. In other words, you need to be observing, you need to be watching, you need to be looking out there and see that. So let's start off here. First thing, context. If I go to England, I go on your farm, first thing I do is pull out a shovel. And this is what I'm going to assume. Most farms and ranches came from the forests and the prairies and grasslands and savannas. This is what we have done in the last 100 years, maybe thousands of years. We have done that. We went from here to here. This is the same soil, ladies and gentlemen. This picture is the same soil. It went from 6 to 8% organic matter, maybe 10, 12, all the way down to 1 or 2%. That's what we're dealing with now. And so please understand that is happening on a national and global. So when I come onto your operation, I assume that it's degraded until I'm proven otherwise. That's our context right now. These soils were once the same soils. So if we can get to the next slide, because I'm getting the lag here. There we go.
Oh, sorry, I'm going to jump in again, Ray, because we've had a question come in about measuring soil carbon over time and how accurate that is. And this person said that is asking, can soil carbon change for reasons that are outside of our management control?
Yes. You know why? Microbes are always eating. Whether you are, even if you're not part of the system, microbes are always cycling. An aggregate, which is a carbon-based biological glues, they're being cycled every 27 days. That's why Jamie, I am not a big fan of paying farmers for carbon. It's a really stupid idea. It's like me, Jamie, paying you for your blood sugar. If you have a drought, carbon goes down. You did one tillage event, carbon goes down. You overgrazed, carbon goes down. It changes every day. That's a dumb idea. People weren't thinking that one now. If I'm going to pay farmers, pay them for biodiversity. Biodiversity. How many insects? How many birds? It's a simple, much easier parameter than paying for carbon. You're paying people for the blood sugar. That's how quickly carbon cycles through the whole planet. It's ridiculous. And it's a temporary storage. When you say I'm measuring organic matter, that's temporary. And we had it wrong. It cycles way quicker than we think.
So that's really interesting. I think quite a few people who are listening in are possibly measuring their soil organic matter. And if people would like to type into the question box, you're very welcome to share if you have measured your soil organic matter, what that might be. Because most people listening would be pastoral dairy farmers who would possibly not regular tillage, but it's interesting to know what is kind of considered normal, what's poor, what's good. And if we did flick back to that last slide, you can see it very visually, but I presume that the difference is not normally that stark when you stick a shovel in the ground. How much can you see when you're just looking visually, Ray?
Right, and the grazing system I'm going to show you when we do that video, Jamie, you'll see that grazing systems are much more stable. I'm going to tell you right now, that makes a little more sense. But in cropping systems, no way. But we're going to show you in a grazing system, when I show you the video, how carbon's diminished in overgrazing and taking too much. And over application of manures with lots of nitrogen can also diminish carbon. I don't think people understand. Microbes want two things: carbon, nitrogen. You put a bunch of manure out there with a lot of nitrogen and too much chemical fertilizer, you're going to diminish carbon also. So that's the thing, is you have to be careful how you do your management. And that's the thing that's an issue. So, okay, so let's get through these 4 ecosystem processes. When I walk onto your place, I get invited to your places. First thing I do is pull out a shovel because I want to see, and I'm going to watch on the top of the surface, how are you capturing sun? That's my number one thing. Are you turning light energy? Are you changing those particles of light and those waves of light? Are you capturing that and turning it into sugars and the 100 compounds? And also understand that the water cycle is connected to the plant. You can't have a water cycle without a plant. And no water cycle, no nutrient cycle. And the last picture on the lower left here is biodiversity. The planet, I call biodiversity the software of the planet. Our phones are worthless without software. Without diversity of life, insects, animals, human beings, this planet would be a rock floating into space. So please understand all these 4 processes need to be occurring every square foot of your dairy, period. And it's really easy to see that happening or not happening. So Emily, go ahead and put it to the next one, please. I think it's faster if I just say next slide, because by the time I'm doing it here, the lag is just brutal. Uh-oh.
Difficult to realize the difference in rainfall runoff between a continuously grazed pasture versus a rotationally grazed pasture. To really see the difference, you actually have to be out there during the heaviest thunderstorm of the year. NRCS uses a rainfall simulator to demonstrate the effects of infiltration versus runoff on pasture surfaces. These pasture samples were collected from actual pastures just down the road from each other. One represents continuous overstocked and overgrazed pasture. The other represents a rotationally grazed and rested pasture. All rainfall runoff is funneled into a collection jug on the front of the demonstration table. This allows us to visually compare both the volume and clarity of the runoff.
Most important nutrient we have to manage is water. With rotational grazing, particularly during the summer, we have more water infiltration because we have a better cover on the ground. Essentially, the cover intercepts the water particle and allows it to enter into the ground versus running off.
By the end of the demonstration, it's amazing to see how much more runoff occurs on the continuous overgrazed pasture versus the well-rested, rotationally grazed pasture. Here you can see how much more water actually soaks in and absorbed under the rotationally grazed, well-rested pasture, and how much more water actually runs off the
Ray, I just need to remind you to unmute yourself, please.
And see, Emily, boys are slow to learn. That's why I've been married for 34 years and my wife still hasn't trained me yet. Okay, folks, this is important to understand. Thank you, Emily, for remembering to stop this at the exact. This is a teaching moment. Now, I have been on hundreds of dairies, and what is common is what I see on the left. Now, this rain simulator is about 1.5 inches. Those pans are 1.5 inches. We rained about 1.5 inches of water or more. Notice on the left, most of it ran off. Very little infiltrated. Now, there's no tillage going. There's no tillage occurrence, just overgrazing. Now, the picture on the pan on the right is properly managed grazing, adaptive grazing, good grazing occurrence. Look how little ran off and look how much infiltrated. So, Emily, why did the one on the left run off so much? And audience, open it up to the class. Why did the one on the left run off so much and the one on the right did not? Any comments?
So I can come in with comments related to the vegetation on the top of the soil, basically, right?
That's good. That's good. But that's not the answer I'm looking for. You get partial credit. Partial credit. That's good. What else?
I've got compaction.
Yes, that's another one. That's still, you get 2/3, but you still didn't get the full credit.
We've got one is grazed down more, and roots holding the water.
That's good, but still not full credit.
We've got poor infiltration rates, soil structure. Lots of people referencing soil structure.
Okay, what do they mean by soil structure? That's not the term I want to hear. It's a very special term. How about Emily? Did she make any comments?
Tegan, what's your thoughts?
I was going to say about airspace.
It's related to that, but you know what I was wanting to hear is aggregate. Aggregate is the fusion of sand, silts, and clays created by biotic glues. They create those pore spaces. And that is biological. Who would have thought that infiltration is biological, not only geological, sand, silts, and clays, but predominantly biological. So when you overgraze and you take too much canopy, it takes a lot of energy for the plant to feed microbes and fungi to create aggregates. And those aggregates get consumed every 27 days. So if you're overgrazing, which is very typical, you're not giving long recoveries, not only it affects infiltration, it affects the structure. Aggregation and structure are connected, but it really is aggregates. Aggregates is the fusion of the sand, silt, and clays, and so it's very important. Let me show you the next video. Let's go to the next video.
The continuous grazed pasture.
This soil has been tilled for 30 years. It is addicted to chemicals and fertilizer. This soil has not been tilled in 40 years. It is covered with diverse plants year-round. It is completely weaned from chemicals and fertilizer. Watch what happens when we drop the soil in the water. Notice how the conventional till soil is falling apart. The biotic glues in the organic matter are burned up by tillage. The soil pores have collapsed. Look at the no-till soil. It's holding together.
Okay, so what you see here, folks, these are the same soil types. Same soil types. What you saw on the left was a conventional vegetable farm. Tilled. You wake up our strategist bacteria, they eat the biotic glues. You couldn't no longer hold the sand, silts, and clays anymore. And on the right, same soil types, 6.5% organic matter, no-till, cover crops, same soils. So please understand that those biotic glues, so you're gonna have to speed up on that one and keep going, there we go. And so keep in mind, tillage did that, overgrazing diminishes the aggregates. Also, guess what happens? When you leave the ground bare and you leave it fallow, the microbes will consume and cannibalize the carbon in the soil. So think about it, the soils have to eat all the time. So, and over-fertilization also diminishes the aggregate. And you know what else does? Planting legumes. Too much legumes also diminish the soil structure and the pore. Because remember, microbes want nitrogen and they want carbon, and they're going to balance their diet. And if you do not provide the carbon in the living roots, they're going to cannibalize the house. It's like you have these starving kids that say, "Mommy, I'm hungry." No food, eat the house. That's what they're going to do. So back, one more slide. Go back on that slide. The one, there we go. Now here's the goal. Prairies are always covered 24/7. Long recovery times. Forests have animals. I keep telling people from all over the world, we will not heal the planet without grazing animals. Get it over your mind. I don't care if cows fart. We cannot heal the soil without living, grazing herbivores. They both have it 24/7. They're both capturing. They're run by diversity. This is the goal. This is the goal. So I have to stress that this is what, so my grazing systems have to mimic the prairie. So let's go to the next one, and we'll continue down our journey. Now, most people do not understand that our soils have design. What you're seeing here is the design. When I pull a shovel, every shovelful, I want to see a phyllosphere. That's the leaves. Phyllosphere is the surface of the plant. Microbes live there. I want to see living plants. I want to see a living skin called the detritus-sphere. So when you guys go out there on your lawn, on your grass, if you don't have any snow, pull the grass blades to the side and look in the bottom. You'll see this skin, this residue. That's called detritus-sphere. Every plant does that. It protects that soil, creates a layer, keeps it cool, suppresses weeds, and that detritus-sphere is about 30 to 35% of it goes into organic matter. And so that skin is critical. So you want to see every shovelful, I want to see skin, I want to see a drillosphere, an earthworm sphere. Notice they're called spheres, areas of influence. Here's an aggregate, ladies and gentlemen. This is an aggregate. This is look at the sand particles. They're being fused by those biotic glues. They're carbon-based molecules created by fungi, bacteria, living roots. They create the aggregate, and of course, the living root. So these are all, and inside the aggregates-sphere is the porosphere. All spheres need to be present all the time, every time. And so what happens, tillage destroys all that. It buries it under, and it gets consumed. So we got to be careful about how we manage that. So let's go to the next one. Okay, so the number one thing to realize, plant and soil are one. You have to get that in your mind. You have to realize plant and soil are one. They are not separate units. If I take the plant out, then you have no soil microbes. You have no microbes, you have geology. So please understand that when you leave that ground bare or you overgraze, you got to make that plant intact. It's got to be able to capture energy. Let's go to the next one. Jamie, you have a question.
Yeah, we've got questions flooding in, and I'll try and filter as many to you as we can. But there was one asking about, is there an optimum ratio for grass, legumes, and herbs in a pasture?
Yes, excellent question. Yes, I don't like to see more than 20% legumes in a pasture. Why? Prairies are the same. They have about a 20% balance in them. The rest of them are forbs, and the majority is grass. So when I design cover crop mixes, Jamie, it's about 20% legumes. I'm very careful with legumes. Now, if you're going to grow soybean or a monoculture legume, I get it. But the first thing you got to do at the end of the season is do a multi-species cover crop at the end. Because we've seen infiltration rates drop in half with monoculture legumes, in half during the growing season. Why? Microbes, excess nitrogen. Remember, those legumes are leaking nitrogen. And if you got floating nitrogen in the system, the microbes are going to eat the house. What do we expect? So I think we have to understand that, how important that is, okay? So great question.
We've got another one as well relating to pH. Like, is there an optimum pH that we should be aiming for? Is that a relevant measure?
Yes, and Jamie, Emily, go back on that video. We'll start from that slide. We'll start it because I'm going to answer that, and then we'll show this little video because I think it's really cool. Right there, and just right there. Pause it there. Yes, pH. I'm going to be brutally honest about pH. pH is a good parameter, but it's not an accurate parameter. Ooh, what heresy. Dr. Sorsen, who invented pH, pH was intended to be used with blood and water. It was not intended to be used in mineral complexes. We've seen pHs of 5 and plants doing well. And you know, legumes growing, you're not supposed to grow legumes with pH of 5. And yet I've seen that happen. Now, if I have pHs of 4 and real extreme, yes, it's a very crude number. And let me tell you why. Microbes can change pH. Plants can modify pH. Organic matter modifies pH. So be careful how you look at pH. A lot of people go, oh my God, pH. And then also with organic matter, oh, the sacred cow, organic matter. Careful with those parameters. It's about the biological life first in the system. Those are other indicators, but it's only one indicator. I can't hear you, James. There we go.
Just to step back to your previous answer about 20% legumes and the proportions of different types of plants, would that be by weight, by ground cover? What is your 20% referring to?
I do by plant cover. About 20% of your canopy should be about legumes, and no more than that. I try to keep that in balance. And if you have too much legumes in your pasture, it's probably indicative of overgrazing. And so when I overgraze too much on one of my paddocks and it comes all legumes, remember what legumes do in natural ecosystems. They're part of the healing process. They've done some research when they put a bunch of legumes in a natural prairie ecosystem. Guess what happened? Biomass went up, infiltration went down. Careful for legumes, any tool.
So just to take the conversation across to the financial side then, Ray, a lot of people across the UK would be planting and putting legumes into their pastures, generally clover, into pastures with the view to reducing the fertilizer input. You know, is that good practice? Will that be profitable? What would your thoughts be?
Here's what I think, Jamie, is we're looking at it wrong. One, there's already water-soluble organic nitrogen in the soil. First, we had it wrong. We thought plants can only take up nitrate and ammonium. That was wrong. Plants take up amino acids, and they also are rhizophagi. If you look at Dr. James White's work at Rutgers, plants can actually suck up bacteria and strip their outer shell and use them for a nitrogen source. So I'm saying is, if you're looking at legumes strictly for a nitrogen source, don't do that. If you're going to look at them for a carbon source and leaking as part of the system, please understand, don't forget the organic matter fraction. There's water-soluble organic nitrogen. Don't forget about the microbes. But guess what they all need? The most important? Leaking roots. And the ones that do the best on that is grasses, Jamie, grasses. That's why managing the way you graze is the most important thing you can do. Give long recovery times, and the system will cycle plenty quickly for you.
Fabulous. Right, we'll let you carry on with your slideshow, and we'll probably return to that sort of profit.
Yeah, go ahead and click on it. Look at that. The ancient people used to call. Go ahead, Emily, and play that little video. I want people to see the stomata. That's the opening on the bottom of the plant. Look what it's doing. It's bringing in oxygen, and it's it's giving off oxygen, and it's taking in CO2. Look at that. Isn't that beautiful? The ancient people used to call the plant the mouth of the soil. So if you're overgrazing, you've stopped this. And then if you overgraze, then you did this. You're limiting this. The reason our agriculture systems are failing is this photo right here. That is a root leaking liquid sand to feed millions of bacteria and organisms in the soil. This is the problem on most dairies. Overgrazing, overstocked, not enough recovery. This is what makes nitrogen available. Soils will do that. Go to the next one. I think I love that video. It's one of my favorite. And then look at this right here. You'll see this is a prairie system. Look at the lengths of the grasses. This is why grasses are my #1 designer for my mixes. Look at agriculture. Look at the little roots. Look at corn. Look at all the bare ground. Very clearly, if you are not implementing covers or not managing your grasses, you will never be regenerative or sustainable. If the system cannot regenerate itself, you are not sustainable. This is why corn and soybean is an absolute failure. It will not work. without living covers. So we got to get that straight in our mind. Let's proceed to the next one. This is right here. I love this photo because we want to be here on the right. So by the time you leave those grazing cows out in the paddock, you on grass that's already this tall. At the minimum, you want to be here when they've been grazed. You don't want to be here. Most of them are here. And then we start having weed problems. We start having cycling problems. Cycling happens right here. Microbes and these excretions, they make the phosphorus, they make the zinc, they make all those minerals available. It happens here. Here, you're not going to have the cycling. You're taking too much energy from the system. Thank you, that was awesome timing. This is what you see here is a regenerative grazing system. Look at this, look at the colors. The system has enough. The infiltration rate on there is 8 inches per hour on the right. On the one on the left is 1 inch per hour. Go to the next one. Beautiful, beautiful, thank you. So that's the phyllosphere. Now, every plant has a sphere where microbes are actually grazing on. That's called, they're epiphytes. What are they? Why do plants have microbes on them, on their skin? Just like us. They help hormonal function. They're part of the system. So very important. Let's go to the next one. And so again, we're showing the order. Now, click on the next one because we're gonna run out of time. Let's quickly go through this one. And this one is the earthworm. Now, in a pasture system, I want to see about 20 earthworms per cubic foot. The reason I'm showing you this video, if a grazing system should have 20 earthworms per cubic foot, okay? And you do this in the spring, they do immense cycling. If you do not have earthworms, that means you don't have a complete soil web. Let's go to the next one. And so again, now the aggregate. Okay, so let's go to the next slide. In fact, I'm gonna skip the next 5 or 7 slides. We'll jump real quick. We'll wait up. No, go ahead. No, go back a little bit. I'm sorry, but this is important. Back again. Okay, back one more time. Okay, those are aggregates. Look at them, little BBs, little cottage cheese. That's what our soils are supposed to be like. Go to the next slide and you'll see they're like the miniature villi in the lungs of it's like the lungs of a human. We have these incredible villi, the surface area of gas exchange and blood, and it's brilliant. Isn't it look like an aggregate? Same thing happens in the soil. Without aggregates, the surface area, look at this right here, no till without covers. Look at the compaction layer here, and look at here the aggregate. 3 years of cover crops of 5 foot, 6 foot, rolling the cover crops down, went from here to here. Amazing. So we're gonna skip, let's go to slide 38, and then we're gonna, because okay, so the inside the aggregate is those microbes. That's what I want. That's what we want to see. They live in, that's their home. That's the porosphere, okay? So the next slide will show you, the next couple of slides, again, the order. This is the detritosphere. Every grazing system should have this. We should have a little, some people call it a duff layer, some people call it residue, I call it skin. 80% of all insects continue their life cycle in that first 2 inches. I want to see that. But if you're overgrazing, you're not going to have that problem. Let's go to the next one because of time. And again, you'll see in cropland, look at how many bacteria. Same thing of bacteria per teaspoon, but look at the difference in the fungi. This is the huge difference right here. Look at the critters, very different. Look at the numbers. You can see that earthworms, again, for every cubic foot of soil, I want to see a minimum of 20 earthworms. Emily, let's go to the next slide. Okay, now this video I love. It's one of my favorite. This is the nutrient cycling. What you see here are the mesofauna, the critters, the grinders, everything you just saw the previous. This is about 30 to 35% of all organic matter comes from the surface of the plant, of this residue. Only 30 to 35, 60% goes off. The CO2 is in the atmosphere. CO2 is not a poisonous gas. It's a natural gas we need, and it's only 3% of the gases in the atmosphere. A gas that's even more brutal is water vapor. So I wanted to show you that. You screw this up. Now, how do we screw this up in the grazing system? Overgrazing. You don't have enough skin. You're taking too much from the system. So let's go to the next one. And right here, every natural ecosystem, healthy soil will have a skin. Leaves, grass, your lawn, if you're not mowing it too short, will have a skin. So again, let's go to the next slide. And then let's show that. This is what we're doing in the United States now. We are planting cover crops this tall, and we're planting corn, soybean, pumpkins, melons, tomatoes in a big standing cover like that, and we're rolling it down. Beautiful. And it shows you the picture. When it dies, it leaves that natural skin, and look at that corn pop right out of it. It's amazing. Okay, so we go to the next one. The question was asked, what do we do that's causing all these problems? It's right here, folks. Too much tillage, over haying, too much pesticides, over fertilizing, over manuring, leaving the ground bare, all hurt the soil. And so if you go back one slide, there we go. This is a common thing I see throughout the country of the United States. I see dairies with grass that short. Horses are the worst. I've done that several times. We had a massive drought. If you go now in some of my paddocks, it looks like that, and it drives me insane. Drives me nuts. We don't want to be here. That's why I just stopped. So I just pull out a shovel, great indicator tool, go to the next one, and look at this. Beautiful. I want everybody, when you get a chance, start to cool down, go to your fence row, go to your forest, go where it's not been disturbed for the years. This is what you'll see, and this is what we'll see in tilled grounds or even dairies. I will tell you, the outside the fence row will always look better in general, unless you're doing that most of the time, than the existing grazing system. Do you know where I do the benchmark for the biodiversity? Right on the edge. It looks better outside the fence than my own paddock. Drives me crazy. Not enough recovery. So now we're going to go quickly over the one of the other indicators so that we can open up for questions and answers. Okay, I'm going to talk quickly about this, and you're going to just zoom through these slides. Here's the first one. It says all soil tests are wrong. It's okay. All soil tests are wrong. Some are useful. Where do we get that? All computer models are wrong. Some are useful. Here's a mineral theory model. For the last 100 years, we were taught in agronomy and soil school that we were taught the mineral theory. This is partially true. We forgot the biology. We thought, well, if it rains, water comes into the solution, and for some magical power, all these nutrients are floating in there, and then diffusion happens. They become soluble and then there's diffusion from the mineral, then the mass flows into the root, and then the plant intercepts it. That occurs. But guess what? They forgot the most important part. The microbes and the biology. They're the ones that bring it out of the solution. Oops, we missed half of the story. So now, when we talk about this new Haney test, let's go to the next one. When we talk about the Haney test, this is a new test. It's a biological test along with the old soil test. In other words, you have two tests in one. This was created in 2011 by Dr. Rick Haney from ARS USDA. I came across Rick, and a lot of people don't realize, they get confused about the Haney test, the regular soil test. Please keep in this mind, when you read the Haney test, it is apples and oranges. The old test that they're using in Europe, in the United States, is a chemistry-based test. It is not a biological test. So do not interpret the Haney test with your chemical physical paradigm. Now, the slide that we just passed through a while ago in the second was to show you the lab and the sophistication. These are the parameters that the Haney test measures: extractable organic carbon, the efficiency of the microbes, MAC, extractable organic nitrogen, water extractable. Notice I use the word water because soils, they're subaquatic. This is another parameter, organic carbon nitrogen, water organic, the ratio of nitrogen to P, and then 1 day respiration. We've known about 1 day respiration since the 1900s. The Russians knew the higher the respiration, the higher fertility. Extractable organic carbon is the groceries. Okay, let's go to the next one. Again, that's just showing you the sophistication of the lab when you take your test. Go to the next one. What you see here is the Haney test. It's called H3A extract. An extract is the amount of acids they apply so they can compute and do a calculation of how much is going to come off, phosphorus, potassium, and all that. This is the old one. We based it on caustic chemistry. That's not biomimicry. Rick Haney test uses 3 gentle acids from the roots. Wow, a scientist that says, hey, why don't we mimic nature? Let's go to the next one. It's these roots and the fungi. This is a picture of Arbusca mycorrhizae actually releasing these powerful enzymes with the help of roots giving off acids. They scar the rock and make the nutrients available. Very cool. I just wanted to show you that it's biology that does that. Now, these are water-soluble, very sophisticated equipment. So when you send that Haney test in, it'll give you a direct read of the water-soluble carbon. That's the grocery store. Let's go to the next slide, and we'll talk about that in a second. The Haney test is kind of like a blood test. It's kind of like the blood test. Why people use the blood test? Because it's powerful. It's a passive test that tells you, hey, this is where we're at. And it tells us how much your hormonal function, what you're doing, what your body's a great indicator. The Haney test is the same way. You got a question, Jamie?
Yeah, so the Haney test is new to most of us in the UK. Is it available outside of the US?
Yes, it is. And I will show you how to do that. And Jamie, I'll send the information that you can actually send it from lab to lab. You can't send it directly. It's an international thing. And I got the paperwork so you can fill it out. And maybe too, Jamie, before people do that, I would like, it'd probably be good to have a more, another webinar on just that so they can get ready, because the test costs $60. Don't be, I want you to understand, we're not going to have enough time to explain the test correctly so that you know how to read it yourself, because this test can save you thousands and thousands of dollars. We have farmers that have saved millions of dollars on fertility, depending on the size of your farm, by using this Haney test. So this is exciting because we finally have a test that comes close. But remember, Jamie, keep the audience intact. All soil tests are wrong. Some are useful. This one's useful, okay? So no one test can tell you the complete function and health of your soil. If they do, walk away from them, okay? So thank you, Jamie. That's a great question. So let me say this. This is what the Haney test picks up. Most old soil tests pick up nitrate, nitrogen. They might answer ammonium, but the Haney test picks up this. Do the next slide, Emily. Click on it, please. There, look at all those water-soluble organic nitrogen, all of those molecules, amino acids. The Haney test gives you credit for all that, folks. It's exciting. This is finally, we're going to give you credit for what's in the soil. We now have the technology. Go to the next one, please. We'll zip through the next slides and see these. So again, this is geology. What the Haney test is, it has the ability to measure all those organic molecules, those biotic substances, and the organic nitrogen, the organic carbon. We can give you credit for that. All of it that's available right away from the microbes. So when you guys talk to me about organic matter, you're really telling me about the house. That's cool. I like your house. But what I care about is the refrigerator. Who cares if you live in a big stinking house if you only eat hot dogs every day and there's only hot dogs in the refrigerator? Life sucks. Okay? So, and now some of you would say, yeah, but if it was a pub, I'd be good. Yeah. There's always some of you like that out there. So, but let's go to the next one. And so This is what we've been missing, folks. We've been missing over 50%. The current soil tests only measure inorganic N. This is the organic N. This is what we've been missing. So let me show you how. We'll go to the next slide. Now we'll take it to a dairy. I'll show you a couple of dairies how I use this test. And everyone should have, I don't know if I send you a copy. I think I just remember now, I forgot to mail that to you guys. I will send it to you. And this is kind of a sheet that kind of helps you interpret the Haney test, okay? I did mail the explaining every parameter, and I'm not going to go through that right now, but I'm just going to tell you when you get my one tonight, I'll send this to you. And over here is all the indicator parameters are on the Haney test. And these are the ideal range I want them to be in. Right here is the range of, I came up with this range. We did up thousands and thousands of samples all over. So if your Haney test comes back 0 to 7, that means it's 4. 7 to 14, it's fair. Good is 14 to 20. Excellent is 20 to 50. I want to see grazing systems, pasture systems should be here. Here, I want to see that. Let me give you an example. Okay, for example, this is the groceries. Look at this. If you go across water extractable carbon, the food, the respiration, I want to see over 200 parts per million. We're going to talk about that in the Haney test. This is the efficiency of the microbes to process the groceries. This is the balance of organic nitrogen versus inorganic nitrogen. When you hear the word organic nitrogen, guys, that means a carbon molecule is still attached, okay? I need to know that. And then this is the traditional soil test. We'll talk about that. And then the Haney test and the traditional P and the Haney P. And this is how much money you're saving. Now, these are organic. This is an organic pasture dairy in Ohio. And this is an organic dairy with lots of tillage and cover crops. Look at the difference in organic matter between these two. Look at this, just a dairy. I mean, it's a pasture raised dairy. They do no tillage, no cropland, nothing. Look at the water soluble. Look how much energy. I told you I want 150 and above. Look at this, 271. Look at this one, 152. Yes, go ahead, Jamie.
I think we are maybe struggling to see some of the information actually on the slide, but I just wanted to point out to our audience that are listening live, these are loaded on to the handouts, which if you found the questions box, there's a handouts tab just underneath, and you can actually find all of this in that area.
Did I send that one? Jamie, did I screw up and not send this up?
No, I think we've got a few handouts loaded on there, so invite people to download and open them and have a look in their own time.
We're not going to go too. I'm not going to go too detailed, but I think what I want to do, Jamie, because this is too much information, and that's my fault. I tend to overload people because
It's really good. So we do believe that we've got them all in the handouts area. If anyone's struggling, stick your email address in that questions box and we can follow up and send them out to you via email. So we've got a backup plan.
Good. And here's one thing too. Thank you, Jamie. And the thing is about this, guys, this cheat sheet that I created will help you interpret the test yourself. And the thing about it is, it's no problem coming back and do another one of these webinars so we can just focus on that. So you understand it, but this test has an incredible amount of ability to manage nutrients correctly, because dairies over apply manure and they should not be used chemical fertilizer, period. And if you're using chemical fertilizer, then we got problems here. And it's usually the wrong soil tests too that do not help. Okay, so we keep going down look at respiration. Remember I tell you, I want to see 200 and above in respiration. Look at the dairy, this one 286. And look at the other one, 53.3. These other systems I'm not going to talk about right here because these are just cropping systems. But notice the one, I will mention this one right here when I put my thing. This soil right here was the dryland champion this year. His name is Russell Hidrick. He grew 459 bushel corn per acre. You can convert that. You'll just type Russell Hidrick and you'll know that that's his soil here. But I want to go back to here. Like a squirrel, I go nut, you know, and I tend to do that. But let's focus here. I want to see carbon, and I want to see this range here. I do not want the carbon to organic nitrogen ratio. I don't want to see that over 20 or 25. I want that below. Notice all of them are behind, except this one's reaching that. That means if you have too much carbon in the system and not enough nitrogen, the soil's not going to cycle. That's what that's telling you. Now, here's the traditional soil test. A traditional soil test says you only got 14 pounds. The Haney test, no, you got 72 pounds because we give you credit for the organic nitrogen, the ammonium, and the nitrate. The old test in Europe and the United States and globally, the conventional soil test, now you only got 14 pounds. Here's the thing that drove me crazy. When we did a soil test in the forest, in the prairie, they would say they have no nitrogen, none. I said, well, how's the trees growing? How are the prairie growing? This test says, oh, no. We can give you credit. Same thing with the traditional P. Look at that. Look at the difference of the organic P. We can give you credit. This test saved that person $37.25 per acre. Look at the soil health score right here, Jamie, 25, and look at right here, 9.4. Look at the difference. That's a 9.4 is the soil health score. Look at these two dairies and how they manage and how different the nitrogen contents in them. Go ahead, Jamie.
So we are struggling a little bit to keep up with you on following you around the boxes. I think we can't see your mouse actually, Ray, but we have got lots and lots of questions coming in. So if you don't mind, let's get into some of those. We've got one, I'll kick off with, have you any opinion on the use of biochar as a feed additive to mitigate cattle methane emissions, reducing the impact of worms, those kind of things? And there's somebody else was mentioning biochar in soils as well. So can I draw you onto the subject of biochar?
Yes, I like biochar, but folks, I really believe that managing grazing properly is way better than biochar. Look, biochar is great for people that have a lot of wooded area and have that resource. But really, think about the first 6 inches of the soil. It weighs 1 million pounds. And you put in a little biochar, is like a pimple on an elephant's butt. Or you're like spraying against, you're peeing against a tornado. Good luck. And people say, well, it's good habitat for the microbes. Look, I'm not opposed to any of that. But an aggregates do this, folks. Aggregates do that. They create extra charges. They create the habitat. Let the natural system do that. I am not against biochar. Please don't get me wrong. I don't want people saying, oh, Ray, you're against biochar. No. I'm a minimalist. Everything costs. There's a cost to everything. Let the natural system do it. Manage the cows correctly. I'm more excited about putting some microbes. Right now we're knowing called biocommunication, using kind of bio extracts like Dr. David Johnson. We're seeing more response with that than biochar or any of that. Biochar just provides habitat. Aggregates do that already. Why would I do that? I'm not spending money. Aggregates do that. So I'm not against biochar. Biochar works really well, I think, in very, very degraded soils. And you want to get a head start, I think that's great. In our grazing systems, to offset, no. For burning all the carbon to create biochar, you're sending off carbon into the atmosphere. What are we doing? So I have my issues with it, but I also think it's a great resource.
Okay. And we've got several questions coming in about the quality of grazing. So people expressing concerns about if they leave the vegetation to grow too tall, that they're losing grazing quality, for milk production.
Let me show you that, guys. I work with dairies. Let's go to slide 78 and 79 and 80 to address that, please.
Okay.
Let's go to slide 77. I think it's better to show, Jamie, because I think that's exactly what needs to go, because at the end of the day, these are the soil tests. Go on, continue. Keep going. Okay, and let's go to the slide 77. Okay, right there. Okay, dairies, you guys we know with dairy cows, you got to give them enough nutrition. That is a dairy. That's a dairy. That's what I see. That is a common dairy where it's overgrazed. And then you go back one slide, when it looks like that, you're diminishing this right there. Now you're going to have runoff problems. Now go to the next slide again. Okay, let me tell you what happened in that dairy. We had a 5-inch rain. We had 2 or 3 inches of rain. All the water ran off, and it was dry after 2 inches. Water didn't enter. Look at here, the forest. Look at the forest soil. Look at the pasture soil, guys, in color. We're overgrazing. So what you got to do is you got to give the dairy cattle, way more room, but longer recovery. So how do we do that? You got to break up the paddocks more. Break up the paddocks.
Can I draw you to quantify what you're talking about when you talk about longer recovery periods? I mean, like conventionally in a lot of our rotational grazing systems here, people will be, I don't know, a 21-day grazing round, for instance. So they'd be coming back to the same pasture within 21 days. But what lengths are you talking about specifically here?
Okay, I get 45 to 46 inches of rain, okay? I get 45 to 46 inches of rain. I'm in a subtropical area. I got a lot of rock. I'm trying to get my paddocks broken up so I come back in anywhere from 40 to 60 days. Then I'm seeing, when I did that, I had one paddock rest a whole year. And guess what happened, Jamie? I found native prairie grasses that I never saw in my place express themselves. I was shocked. Give it a whole year rest. I know that's not practical for a lot of people. I get it. But if we can go to 40 days to 60 days in an area, because you guys get about as much rain as we do. I don't know how much rain you get, Jamie, but it's a function of moisture. And the cow, you got to look at the cow, how it looks. But look at this next, let's go to the next picture before you answer one more short. Let me show the next one. Look at the body condition score on that one, Jamie. Look at those dairy cows. That come from that dairy. And so what's happening is, the way this model is, they'll graze it, they'll plant annual rye, and they fertilize the heck out of it, and then they graze it to the dirt. And once the grass they wore out the grass, they'll plant it. This is a 3-4 year cycle. And they'll plant it again, fertilize, and look at the body condition score of the animals. Overgrazed, too many people.
That leads us really, really nicely into a question that lots and lots of people have been asking. If we are conventional fertilizer users, and decide to stop, how long do you believe the recovery of those soils would actually take?
Here's the thing, I want to give people proper context about fertilizer first. Fertilizer is a salt. It's kind of like, it's a salt. And what they did is, everybody knows the Haber-Bosch process, pretty much everybody knows. It's a nitrogen source. Usually people put urea out there, and it's a salt. And people see a little bit of response, but a healthy soil will not respond to nitrogen fertilizer. I'll say that again. A healthy soil does not respond to nitrogen fertilizer. It cycles pretty much on its own. What I have had my farm 6 or 7 years. I would refuse to put any fertilizer out there. It doesn't need it. What it needs is for me to group my sheep tighter, and that I want to see about 1 foot to 2, 3, 4 feet. I want to see a manure and the cow pie. I want to see a cow pie about 2 or 3 feet apart. And in between there, I'll see a urine patch. Urine can have all the way up to a couple of 100 pounds of nitrogen in it. So in a dairy ecosystem, you shouldn't have to be fertilizing. It's really about the grazing system that's going on. And so it's about your plants, your pastures will respond very quickly with longer recoveries. I think in the dairy industry, and I have to deal with dairy guys all the time. I deal with thousands and thousands of acres. I mean, big dairies. And here's the problem. What's pushing the problem? Yield. The dairy people have, well, I got to get milk and I got to pay for the bills. I get it. But you guys are no better than the corn guys who are monoculture, who are being pushed by yield, but it's really what the money is, investment. I mean, how much money are you getting on investment back when you put that fertilizer? We have recent research have shown when we put fertilizer out there in some of our grazing systems, we're really not getting the financial benefit out of it as people think they are, and the high cost of it. And it's going to be more and more expensive because of the Russia and all these other things. I keep telling people that we do longer recovery, split the paddocks more, let the cows get their room, but move them more frequently, which people aren't willing to do. Then that's the problem. It's fertilizer in a pasture ecosystem, guys. It responds very quickly to wean itself. It's just more longer roots and longer recovery. That's the issue. And I think we can do amazing things. And another thing I want to show, let's go to slide 88 real quick, Jamie and Emily. Let's go to slide 88. Another thing to offset the pressure, what I think is happening in dairies is this slide 88. I think this is a good one. That's 86. Go 2 more slides down. Let's go to 87. Okay, back there. Let's go back there real quick. 87. Let's go to that one real quick. Back. Okay, that's the lab. Everybody has that. You have a copy of that. Go to the next one. That's the lab. It's called Regen-Ag lab, okay? Do not send it to any other lab in the United States. Don't do that, because I'm not putting my name behind it. This is the only lab that is doing it Rick's test correctly, okay? It's called Regen-Ag lab. It's in Nebraska, and I got the paperwork, and I'll send it to Jamie so that you can send that over there. But I wouldn't do anything until we go over the Haney test a little more time, because right now this is. Now let's go to the next slide. I think this will help take pressure this way.
Ray,
go ahead, Jamie.
You're talking about pressure and things, and I've got a lot of people asking about grazing pressure, stocking density. When we were back looking at the pictures of the dairy cows that were, you were saying were overgrazing, what kind of stocking densities would you be talking about that you're working with on farms in the US?
Okay, I work with dairies all the way from 10,000 cow dairies, 10,000, anywhere from 100 to 10,000. And how much per acre, you're saying, right?
Yes, please.
Okay, that's going to be a function of your context. Whether you're in Texas, Missouri, that's a pressure. That's determined by how much water and how much AUMs and how much you want to get out of that, how much that animal can handle. So that varies on your ecological context. So for me to give you a prescriptive number, I'm not going to do that. I will not do that until I walk your pastures and see them and we do clip counts. I'm not going to do that, because then you'll have a failure and you're going to be pissed and you're going to blame me. And my name is Jamie McCoy. Okay.
Thanks very much.
Yeah, and see, that's the first thing. That's the first thing they want to do is they want me to give you a prescription. It doesn't work that way. I got to take your ecological context into bear. Your animals, how they look, the size, the frame, everything. You just can't do that.
You just said something and I didn't catch you quite right there. Did you say click counts or something? When we walk, you said can't give you a number because we need to walk the pasture and do
context,
some counts.
It's called
the counts you're referring to?
Context. Yeah, I called it ecological context. Context is everything. What are you animals? Are you Holsteins? Are you a smaller framed animal? How much rain are you? Are you in Colorado? Are you in Texas? You get 20 inches of rain? You get 30? That's all that has to take into place. Ecological context. That's what I meant.
Okay.
Okay. So let's show them one more thing. I want to show them something real quick here. Let's go through the grazing one more thing, and I'll show you Alejandro's real quick in the desert with 6 to 11 inches. But I want to show how powerful about context, about grazing context, Jamie. So I think that'll help them understand what I mean by context, about your numbers and all that. And I think that would help because if we can do this in the desert and the movements, these animals, notice that picture we have right there, Jamie? That is how we're moving our cows. We move them in large groups and we mob graze. And I know dairy cows are different from regular cows. I get it. They need to be given more room. But what Alejandro does is gives long recoveries and he moves the cows quickly. Let's quickly go through some of these slides and then we'll wrap it up for we'll not wrap it up, but we'll answer for questions. I'm here for you guys. Okay, let's go to the next slide real quick, because I think this is extremely important because we're talking about the grazing. To give you guys perspective, I'm in New Mexico. I grew up there. Oops, what happened? I didn't touch anything. There we go. And what we're, so I'm going to show you, okay, that is the Chihuahuan Desert. Just to give you perspective, guys, 6 to 11 inches. That's about 145 to 245 milliliters of water per year. That's it. It's hot there, folks. It's a desert, but it was once a prairie. It's got 600 cow calf operation, 4th generation. He's going to be on the next Common Ground documentary. So let's go to the next one, and I'll show you what we're talking about here. Next slide. Okay, now there's a great paper called, because I wanted to, okay, let me tell you, give you a quick story background. When I drive from Missouri to New Mexico, it is brutal. We're becoming more and more desertified in the West. And I could not figure how in the world are we going to be able to fix our grazing lands, from pasture to our grasslands. How are we going to fix them? Thank goodness people like Ellen Savory really helped me a lot, which helped Alejandro. But I did not understand until I went to Alejandro's ranch how he was moving the cows and how we're trying to mimic that even in grazing systems. I don't care if you have dairy cows, whatever. We're trying to do the same concept. And the concept is this. You see this picture here this is called mobile link organisms and ecosystem functioning. What this is talking about is, here's a good paddock. Imagine this paddock here, and there's a degraded paddock here. By using the cows, it's called a resource link. Cows move their manure and their urine to the next paddock and stimulate nutrient cycling and all the ecosystem processes. What Alejandro does, he's created many paddocks so that you give long recovery here, and then you move the animal, pick up seed and urine and all this other here, and they'll move it to the next paddock and start the cycling in the ecosystem process. Let's go to the next slide to show you how that's occurring. Oops. I'm wondering if I'm faster. There we go. Notice on the cow, what's on its hide? Seed. They carry seed in the manure, their urine, I mean in the hoofs, and their dung. So you're taking seed from one place to another, and you're doing the same thing in your paddocks. Believe it or not. If you let them express themselves, you can have that occur. So go to the next one. Because mine's not fast enough. Uh-oh. I guess we're having.
I think we're having a little bit of difficulty, but bear with us.
Let's do this. Let's skip a couple of slides and let's go to slide number, and we'll show this last slides. And I think then we can open it up for discussion. I think these are 4 powerful slides. Okay, here's what they've done. See all the watering and the fencing system? Alejandro's got took that 12,000 hectare ranch and broke it up into 300 paddocks. Go to the next one. One hot wire, look at that. One hot wire to hold those cattle in. One hot wire between the paddocks, real cheap. Let's go to the next one. Next one, and it's split over 150 feet. This is what I want to see, the powerful of the way of the cattle. Go to the, okay. See, they even run hot wire up those cactus and up those ranges. Go to the next one. And so people say, well, Ray, I don't have enough time. Now look at the Telemara. Those are natives. They move the cows 800 times a year. Those cowboys, all they do is move cows twice. Go to the next video. If it plays, it'll be a miracle. Look at that. There's those cowboys moving those cows like buffalo They move them twice a day. 2 cowboys move 500. Okay? And they move them from paddock to paddock. Now go to the next one, look at the results. Then we can open it for discussion. Look at that picture of that hill. Go to the next slide. This is what happens after the disturbance. Look what happened in 2015. Now this is a very dry climate. And look at the next slide. I took that in 2021. That was not planted, ladies and gentlemen. The seed bank is there. The seed bank is there. Now we'll wrap this up and let's go to the next. Okay, actually there's 3 more slides I want to show and then we'll wrap it up. Okay,
Ray,
let's go to slide 106. Yes, ma'am. Go ahead.
We did have a question about seeds, actually, where people do decide to actively reseed, so they are sowing pastures. Is there any benefit to, in a Regen-Ag system, to using organic seed? Having discussion about this, is organic seed bred under conditions which make it more likely to thrive under lower nitrogen conditions, for instance, or does it make no difference, or what would your take be?
Yes and no. Let me be brutally honest. I love organic, but some of the most destroyed soils come from organic farms. Okay, it just keeps some proper perspective. And also, if you have an organic farm, you got everybody conventional, you're getting spray drip still. Now, it's GMO. I have issues with genetically modified organisms. I think if you have plants that are non-GMO, I think that I'm more concerned about that. I don't feed any of my sheep any genetically modified. Now, if somebody does, again, that's on you. I don't sit there and say, oh my God, you're not regenerative because you use GMO. No, I'm more concerned that you understand the system and you're weaning yourself from like, why pay for genetically modified? We're finding out our genetically modified corn yields less than our non-genetically modified. I do not want farmers and ranchers, Jamie, paying for seed. They don't have to. Now, organic, what I love about organic is that a lot of the organics is, I love their attitude. I pay for their attitude. They're trying to get away from the chemicals. That's what I support. And so I'm a big fan of the organic people. And they're the ones to change to regenerative quicker. And they're the ones that actually saw the problems in the system. But you pay a lot more for the seed. I'm more concerned, so I don't want you getting out of your organic certification because you have to do what they tell you to. That's why some of my top no-till vegetable growers are not organic certified because they know more than the certifiers and they're still getting the same money. Okay?
So there's a bit of British context here, I think, Ray, because we don't have GMO concerns here because we don't have it. So we're in a slightly different position. We are running close to time now, and we have had a couple of really, really good questions come in that I would like us to get the time to cover. And I know you had a section that we haven't covered in the presentation about slurry, and I just wanted to draw you to discuss a little bit about effective use of slurry in dairy systems and in regenerative agriculture systems where people do choose to house their cows for a period of the year, how that slurry can best manage on pasture. We'll turn the slides off because I think we're struggling.
Can we do one more thing? Jamie, can we do this real quick? Go to slide 110 and 111 real quick, please. And then we'll go to the slurry.
Fabulous.
And then we'll go to, now keep clicking on those two, please. That's Tom on 5 acres, and he's doing adaptive grazing like Alejandro. That's in Missouri. Look how tiny the paddocks are. He's doing that on 5 acres. That's on a hectare. And he's moving the cows, giving long recoveries. So people say, well, I can't do that. I don't want to hear that. That's not true. It's about moving the animals more frequently. Now, slurry, and I didn't have enough time to cover that, but I will tell you this about slurry. When you use dairy slurry and it's in a lagoon, please be very cautious how much you use. I dilute the heck out of it. I do not put more than 3 to 6,000 gallons per acre. So you guys need to do the math on that. 3 to 6,000, 3 to 8,000, no more on an acre when I apply that slurry. Why? If it wasn't for the Haney test, I would have never fixed it. That Haney test is so sensitive. We had one producer, there was 2 farmers that were using dairy slurry. Now keep in mind, nature does not store manure in anaerobic conditions. Nature does this with manure. The moment it lands on the soil, it's aerobic. Microbes break it down, fungi attack it, the bacteria, you got dung beetles, earthworms, man, it's gone. It's aerobic, not anaerobic. Now, manure in an anaerobic condition, it starts to shift biologically. There's a lot of byproducts and toxins. It's toxic. Can the soil handle it? Yes. This is what happened. We saw where people put too much dairy slurry, the microbial population went down and respiration tanked. I mean, it tanked. The worst part about it is there was no nutrient cycling. And if there's no nutrient cycling, guess what happened? There was not enough nutrients available for the crop. So nutrient cycling went and it tanked. And so the one that did it in a measured amount, 3 to 8,000, and used cover crops in his cropping system, he had 340 pounds of nitrogen available for his crop. The one that used 18,000 gallons of slurry, it tanked, because I used pounds. I don't want more than 3 to 8,000 gallons at a time on an acre. The other dairy guy was using 18,000, population tanked. It just, no cycling. It killed earthworms. It's toxic. You got to be careful. And I love to inject my manure, or I love to leave it on top of a standing cover. And I do not like to till it in because you're destroying house. But in some parts of our country, we're telling farmers to disc it in. I think that's ridiculous. And I prefer not to do that. And so now we can open up for questions.
Thank you so much. Yeah, we are pushing on time actually. So I think what we'll do is we will finish with this, Ray, because we've had a particularly good question come in, which I think will bring everything together. You've talked a lot about, you've got incredible soil knowledge, and, where pH and organic matter is what we've been sort of focused on, I suppose, as a British dairy industry when we think about soils. What are the 3 things that you would recommend that dairy farmers specifically should change to manage their soil going forward to improve the pH and the organic matter?
Please, thank you, Jamie. Good question. Keep in mind, your soils are self-regulating, self-healing, self-organizing. They do that. They regulate their own pH. They regulate the nutrients. The number one thing, if I was to want my soils improved, do proper grazing, lung recoveries. That's number one for me. Longer roots, more leaking carbon. They'll make the nitrogen more available. They will. The problem is we're overgrazed and we're overstocked, and everybody knows that. And that's brutal. Nobody wants to hear that, but that's where we're at. We don't give enough time for that plant to recover, to create aggregates, and increase. I'm more concerned about aggregates, canopy, diversity on top, because I want to run bees on my grazing system. Why? But if I don't have bee, if my plants are so short and I have no pollinators expressing themselves, again, I break up more paddocks, longer recoveries. That's the number one thing I'll be doing in my soils. Manage the cows correctly. And watch your cows. They're indicators. I'd rather watch my cow and a shovel. I dig my shovel. Go to your edge of your field and judge yourself. How good are you? And you're going to find out you're not that good. You're going to be disappointed. So that's what pH. If you got pH as a 4 or 5 or something, and then I'd start worrying. But keep in mind, inside an aggregate and outside another aggregate, it could be a whole pH unit different. So, and the plants change pH. So I don't worry about pH as much as I used to. Remember, I have a biological perspective. I spent the last 15 years reteaching myself. For the first 15 years and the 8 years of university, I had to unteach myself and read the right books. So that's where I'm at.
Yeah. So I suppose it circles back, doesn't it? As soon as you start to learn more, you realize how little you know, and there's so much more to learn. But hopefully tonight has inspired a few people to go out with their shovels tomorrow morning and perhaps dig a hole underneath the hedgerow, or on the field margin, and make comparisons between the areas that we have not been farming as intensively on our farms with the areas that are more highly productive, will we say. So if that's one thing that people can get from today, it's to go out and do that and get a real visual representation of their own farms. Because actually one of the things that listening to you tonight, Ray, has really highlighted to me is that there's huge differences between farming in the US and farming in the UK, but of course there's huge differences between neighbouring farms, isn't there? And just a fence line sometimes can be a world apart, actually. All we can do is the best within the boundaries of our own farms, but look really carefully at what those indicators are and the biodiversity. So yeah, Ray, thank you so much. It's been an absolute pleasure working with you.
Thank you, Jamie. Can I make one comment, Jamie? I want to make sure that we don't leave. I don't want them to leave without this. What's in common with Europe and the United States? It's not just delineation. It runs on biodiversity. It functions the same way. Whether you're in England or you're in the Chihuahuan Desert, it wants diversity. And so it runs on diversity. And the microbes are the same in England and Missouri. I'm sorry, except they speak Missourian here, and yours have a beautiful, better English accent, but they do work the same. And they're indicators. What happened to our universities, this is what happened. We were asking the wrong questions, Jamie. Well, the question should have always been, how do we make our cropping and our grazing systems emulate the natural system? That's what I want you to walk away today with. And we have new soil tests now that they use the concepts of biomimicry. So thank you, Jamie, Emily, and Tegan for being patient. I realize that we should have, the technology is still imperfect. There's nothing better than having me there, walking your fields, and then we can learn way more than we can from here. And so thank you for taking your precious time to be with me today.
No, thank you so much, Ray. And actually, we would love to host you in the UK. If you can make the trip over the pond, we will provide the shovel and some farms to go and have a look at. So that would be fabulous. So just in conclusion, thanks so much to everyone who sent in questions. I appreciate that we haven't gotten through all of them, but hopefully we've had a really good flavour of regenerative agriculture. We've had a little visit to some US farms, and just to bring things back to our title and thinking about targeting net zero here in the UK, we appreciate that individual farms are going to have varying approaches to how they might work on reducing their carbon footprint, but hopefully for those who are looking at the route of kind of reducing their inputs, particularly that chemical fertilizer input, and looking at building organic matter in the soils, I hope this session's been useful, interesting, inspiring, all of the above. I'd just take a moment to remind everyone that there are a range of soils resources available via AHDB, so particularly look out for some of the great soils fact sheets. There's all sorts there, from worm count sheets. We've got a range of webinars on our YouTube channel in the archives, and those range from slurry management through to herbal lays. So there's a plethora of support there if you're looking to make changes on the farm. And if you would like more information, then please do get in touch with your local knowledge exchange manager. Their contact details can be found on the AHDB website. And with that, I'll remind you that as you log out of this webinar, if you're listening live, then you will be invited to submit an evaluation form. We do read your comments and they are appreciated, so do please send us in your feedback. So thanks for your questions, thanks for your participation. Huge thanks to Tegan, and most importantly, Ray. You know, we know that you are an absolute legend in the soil world, and it has been a pleasure to spend a couple of hours with you this evening. Thank you so much. And with that,
thank you,
we will
Jamie.
sign out.